Hey everyone, I'm Jay and welcome to the first in a series of videos that I'll be using in my courses called Intro to HTML and CSS, where we'll be covering an array of topics introducing you to HTML and CSS. We will roughly be following our book, or at least the chapters of our book, not all the content, but Web Development and Design Foundations with HTML5. It's a Pearson book. I'll be covering kind of my version of the highlights from these books, things that are common mistakes I'll be covering, difficult topics I'll be covering, the important parts, generally just the slideshow version of these chapters. So without further ado, let's get started. Right, what we're going to do in chapter 1 or video 1 is kind of get an introduction or a background to the fundamentals of how the internet works. Kind of an overview of this. We won't be talking about any technical detail, not really. But it is important if you're going to be building content on the web that you have some understanding of how the web functions to begin with. So let's take a look at that. And of course, the first thing that we need to get started is a network. Right? The internet is the largest network of computers in the world by far. Right? It is the internet. Right? It's basically all the computers connected together. But any network really just requires two computers, or at least two computers, connected together for communication purposes. Okay? So you can have a local network, which is inside of a single building. Your home network, that's a local network. That local network is also probably connected to the internet. But if the internet goes down, you are still connected locally. You're still connected to your printer. You can print. Those are two computers connected to each other. Right? The printer obviously does a very specific job. You can't do a lot of other things with it. But it is a computer. You are connected to it on a network. And the same thing with any other computers you may have in your home on your home network. You may have a media server for storing videos or something. And you have two computers connected in a network and they're communicating. So once you have these two computers, let's say you have a media server, and then you have maybe your TV is consuming that media from that media server, you essentially have a client and server relationship with those two computers. Right? This is what we commonly think of when we think of computers on the internet. We think of a lot of servers out there in the cloud. And what they do very simply is when a client asks them for a file, assuming they have the authority to access it, they serve that file to them. They just give them the contents. You can protect files, you can have password protection, you can have IP protection, geolocation, whatever you want to have in there. But essentially the server just says, oh, you want this file? Yeah, here you go, and it sends it to them. And that is really the basis of what a client-server relationship is. The client is just asking for information or maybe sending some information back to the server. If you ever filled out a form, the client, you are sending information back to the server. So very much like a restaurant, the server gives content to the clients that they ask for. Hopefully it's the correct content that they ask for. Mistakes can happen. That is sometimes how a hack might happen, or in case of a restaurant, you may get the wrong item. But in a restaurant, you just send it back and you get a new one. On the web, you could just refresh the page or visit a different page, get a new page. Or if you have some other intent, you could use the wrong information that you got for something else. Right? Unlike a restaurant, the servers don't walk around. Okay, keep that in mind. The servers are stationary, the internet, right? That's what the network for the internet is for. It's tying all the computers together. So how do these computers talk to each other? Right? They're going to use a communication protocol so that the computers can send information from one to the other, and then when the other computer gets it, it knows how to understand that information. You just send, maybe you want to send a text file, and you want to send a video file, and you want to send a picture. Computer needs to know how to interpret all these things. So we have Transmission Control Protocol, TCP. And the basics of that is TCP is going to first break down all the files and data that you send across the internet into smaller, more manageable pieces. And what this does is, if you have a really large file, let's say you're downloading a game, you can't just send a gigabyte of information across the internet and tie up that channel so nobody else can use it. So what TCP does is say, all right, we have a gigabyte file. We're going to break it down into probably hundreds of small pieces, potentially thousands of small pieces. We're going to send all the small pieces one after another. And the internet is very large, so these small pieces could potentially take different paths. But even if they all take the same path, because they're one piece at a time, somebody else could also be using that path, and they could kind of do like a zipper merge like we do on the highway or something. So that's the big thing that TCP does, is break these things down into more manageable pieces, and it also gives the receiving computer a method of putting those pieces back together again. So they get broken down, they get numbered, and they have a little information that says, hey, I'm a piece of a file and I gotta go to this computer and I'm number 6 out of 8,000 pieces or whatever it is. So then it goes through. TCP also has, famously, as my little beam over here shows, has a handshake where before two computers will begin communicating, TCP is going to say, hey, I'm a computer, I want to communicate with you. And then that computer is going to reply back and say, oh, okay, I'm ready to communicate with you. And then the first computer will begin sending the messages. So they've first established a connection from both ends and said, yes, us two computers are talking. And then they talk. So like this lady here, she wants to drink some water, and she first establishes that connection between the water bottle and her mouth before pouring the water. UDP, which is just like TCP except for the handshake, it does not establish that connection. It just sends information, and if the other one's not ready for it, it doesn't get it. So just like this gentleman here, he's trying to drink some water, but he did not establish a connection between the water bottle and his mouth before he started sending the water. And the water got there, but his mouth was not ready to receive it. So how do these packets get from place to place? We have additional protocols. I think my slide's out of order here. Let's go down to this one. IP protocol. This is basically like a map of the internet. Every computer connected to the internet has an IP. Your local computer, your local network has its own set of IP addresses, and then your internet router at home has an IP address, probably one given to it by your internet provider. And that IP address is the external IP address for your entire network. This is how multiple networks communicate with the internet protocol, IP. Right? So that IP address gets sent to from computer to computer through this IP address mapping system. And each computer essentially will know all the individual computers that it is directly connected to, that it can reach. And it will send those messages across the internet. It will actually find its own way. If one particular node on the internet is like super busy or goes down, the message will find another path. So as it's going through, it gets to this computer and says, oh, I know this computer, and this computer, and this computer famously finds all the IP addresses between this value and this value, so I'm going to send it over there. And it really does find its own way. It's quite magical. So we're not going to get into any of the nitty-gritty of how that actually works, other than what we've already talked about. So the IP is the mapping, and it will find its own way. It's all based on what the number is. That's also how you can geolocate IP addresses. And so that is how those packets get from place to place, and they don't have to follow the same path. So if you have a TCP connection and you send 87 packets, for example, theoretically they could all follow 87 different paths to get from point A to point B. Generally, they're going to follow a much more limited number than that, I would think. Otherwise, you might be waiting longer for that one packet to get there. So on top of TCP and IP, we also have some other protocols. How computers send specific information to each other. We could use the FTP protocol, and what this is going to do is for directly connecting to computers and exchanging files, very much like the File Explorer on your computer, except that generally in an FTP program, you'll have one file location open up of your local computer, followed by one file location open up on the remote computer after you've established a connection. And then you can upload and download files between the two locations. And of course, you can navigate directories. Assuming you have access to directories, you can navigate them both on the remote computer and your local computer. And you can upload and download files. Traditionally, in this class, that's what we would have done. However, schools are reluctant to give students server space. It's 2021 now, and they've probably seen the evidence that although the vast majority of students can be trusted with FTP access, every once in a while somebody does something they're not supposed to. So schools don't do that so much anymore. And in my classes, I've begun using GitHub Pages instead. It operates kind of similarly, but it's not FTP. So another protocol, excuse me, and we won't be talking about GitHub in this video. I have a different video for that, which I'll link below. Another protocol is Hypertext Transfer Protocol. This is what is used to send between web browsers to and from. So different applications now are using different protocols. FTP is one application, and it can send and receive files. HTTP is your average everyday internet browser, and it will send information using that protocol, which is built on top of TCP and IP. It's still going to be broken into packets. All of these are, because all of the information will be eventually broken into TCP packets and sent across the IP network. Once those packets are put together, then a computer will read them and will say, oh, this packet, once put together, is actually in the HTTP format. And it knows what to do with it because that protocol is standardized. Some email protocols, we have POP3, IMAP, and SMTP. So the email protocols, we have one for sending email, one for receiving email, and then a third one, IMAP. This is for dynamically syncing both the to and from of emails. So if you're using Outlook, for example, Depending on how you set it up, you'd be using either POP3 and SMTP, one for sending, one for receiving. SMTP is for sending. That's what that one's for. Or you might be set up to use IMAP. In either case, these are email protocols that we have. And let's see what else we have here. We did IP. Now we can talk about the DNS system or domain name system. So IP addresses, although super useful for computers, right? Numbered addresses all across the globe telling us where computers are and how to find them. That works great, except that you and I are humans. We don't remember millions of numbers. If we want to go to google.com, what we don't want to do is go to 172.217.4.78. I don't want to remember that. I want to remember google.com. So we have domain name system built on top of the IP. And what this is really simply a list of names and values, right? So google.com points to this IP address. Amazon.com points to this IP address. YouTube.com points to this IP address. There can be multiple servers built on a single domain. That is something built into the domain name system. For example, google.com is one website, but then we also have maps.google.com, we have mail.google.com, we have slides.google.com or drive.google.com. All those things don't necessarily have to live on the same computer. The domain name system could say each one of those points to its own server, possibly collection of servers for a fallback device, because they are super popular and they probably need multiple servers to run those services. But that's how domain names, why domain names are created. Let's look at how a URL works, right? Because a domain name is part of a URL. We have URI and URL. A URI is a Uniform Resource Identifier. Now this is a type of address. This is a type of address that will identify any resource on the internet at all. Okay, and then what you and I are more familiar with is the URL, or Uniform Resource Locator. This is a special type of URI, and this represents just what you or I would consider to be normal web content. Right? So a URL looks like this up here, https://website.com/directory/file.html. Okay, so that's a common website. I also have a link here, which I will put in the YouTube description below, to how URLs.work. It's a handy website that will show us. I actually have this open. Let's see here. How URLs work. You can click on each part of the URL and it will tell you what it is, give you a verbatim definition and a little bit about how it's used. Right? So that's how URLs work. Very cool website. But we will talk about different parts of the domain name section on our next slide, which is here. So domain names are the part of the website that you actually have to buy this part to get it. All right, and the reason you have to buy it is because somebody else's server in the cloud has to maintain that identity relationship between your domain and your IP address, and they have to do that for you. Right? If you did that yourself, you just put a computer on the internet and said, I'm website.com. One, your new computer on the internet doesn't have any authority on the internet. Nobody recognizes who you are or what you do. so they're not going to listen. So you have to pay some other computer, some other service to get that, right? To get other computers to actually follow that information. It says your website lives on your server. So that's what domain names are and what the DNS system does. Once you have a domain, that's this green middle part. That's the part that you buy. You can choose a .com or a .org or a .net or a .us or a .tv or whatever. You can choose those. Those are the top level domains. Somebody actually owns and runs those things. It may be a for-profit organization, it may be a non-profit organization, but somebody runs those things, and they do create new ones from time to time. And there are some amount of rules. So, most notably country codes in the top level domain. Each country will have its own set of rules. They may or may not enforce those rules very strictly, right? That depends on the country, or that depends on the top level domain. For example, .org would traditionally be for nonprofits, but there's not very much in the way of enforcement for that. But there are sets of rules. A lot of companies, when they create their website, they buy their domain, they will buy multiple domains on different top level domains, so that when users type in anything that they're familiar with, they come to their website. Right? And we also have in this red portion right here, so we have the domain. That's the name you actually get to pick. Type out whatever you want it to be, assuming nobody else has it. Then there's the top level domain. These are owned and operated by large internet companies, and you have to buy your domain in association with theirs. Different ones will have their own set of rules on what type of content, and what type of organizations operate on those top level domains. Right? For example, if you're in the US, you have a .gov. It absolutely has to be a government organization, and you have to go through their system just to get it. Or if you want a .edu, similarly, you have to be an education establishment, and you have to go through that process to get that. But if you want a .com, anybody can have one of those from any country. If you want a .us, generally anyone can have those, but they do want you to be based in the US. They may or may not be enforcing that. So those are the top levels, the domains, the subdomains. Once you have a domain in any top level, doesn't matter, you can create your own subdomains essentially to your heart's content. You can make any name that you want, call it whatever you want, point it to whatever server you want. It does not have to point to the same server as your main domain. Like I said, google.com and maps.google.com point to different servers. And that's what the subdomain is. Okay. They're going to point to different servers. They could point to the same server if you had a smaller website that you could fit all your subdomains and they can actually run without overpowering one server. You can have them all on one server. Not a problem. You can have that. You can call them whatever you want to call the subdomain. Right? There is a limitation on the number of characters in a domain, but generally you won't run into that, because if you had a domain that was up to 255 characters long, which I believe is the limit, nobody's typing that. So you're going to want yours to be as short as possible. So now we have an idea of how the internet communicates. Let's talk about our two languages, a little bit of the history of those. Were our HTML and CSS. Okay, history of HTML. Version 1 of HTML started all the way back in 1991. Some of you watching this video and taking my classes We're not around yet. That's okay. I was not programming in HTML myself back then, but I was around. I was not even using the internet yet. I was not using the internet until HTML2 came around, along with Windows 95 in 1995. HTML2 had some improvement. Notably, it added tables, and it also gave browsers the ability to make their own HTML tags or their own element tags, and then browsers could implement their own features that they wanted to. Tables in the 90s and that were used very much for layout purposes, which we will talk about in a later video. Later, HTML3 came around a couple years later, and it supported CSS first. This was amazing. This meant that your page could have a list of CSS at the top of the page and say, okay, these elements are going to look like this, these elements are going to look like this. And then what you didn't have to do is every time you had an element, you didn't have to say, okay, here's the element, it's going to be blue, it's going to have a border, you didn't have to say it every single time. You could just say, okay, all the links are going to be this color, all the titles are going to be this color, all the headings are going to be this color, all the images are going to have a border or whatever. Instead of having to tell each individual one what it's going to look like, you could just set your own set of cascading style sheet rules. HTML4, a couple years later, a big advantage of that is it supported making that CSL in its own file, and then instead of having CSS in each file, which you could still do, you can have one CSS file that powered your entire website, and it made your pages smaller. So instead of having CSS on every single page, you shrunk that down, just said, oh, here's the CSS, go get it one time and remember it. Browsers could cache this, they could save it, and then you didn't have to download it for every page. And from the developer's point of view, it means that you have one CSS file to update, and you can change the look of your entire website, whereas before this, you would have CSS on every single page, and if you wanted to change something, you had to change every single page, and it was a nightmare. We don't like to do that. Shortly after HTML4 began XHTML, which is a highly standardized version of HTML. It did not take the number 5. It started with its own number, again, XHTML 1.0 or 1.1. It didn't make it too far. It enforced valid XML elements. It was a move in the right direction, but it did get some feedback. It was very, very strict, and although it was kind of widely used, it did get some pushback. So HTML5 was eventually created. It had been being worked on for many years. All of these were worked on for quite a while before they were released. HTML5 replaced XHTML. We got rid of that. HTML5 added a lot of new things. It did keep that XML formatting, but it was not nearly as strict in some cases. And then HTML5 added a lot of new elements, added semantic elements, added a lot of new features like ARIA for supporting disabled users, and just a lot of things. And HTML5 is still in development, and it's still having new things added somewhat regularly. So that's some history, very brief history on HTML, and we have an equally brief history on CSS. Remember, HTML started in '91, and CSS was not fully supported until HTML3 in 1997. CSS was first introduced in 1996, but it lacked popular browser support at the time. Remember that HTML2 browsers could start doing their own things, so they did start supporting CSS1, but it wasn't super popular yet. And those were kind of the Wild West days of the internet, so there actually was quite a few browsers that people could choose from. So even if one supported something, that was not necessarily very much of the market share. And then in CSS2, a couple years later, this one was widely popular, and it used it was used for a lot of years. As you can see, CSS 2.1 wasn't even released until 2011, so a full 13 years later. There were some issues in CSS2 that were corrected. Browsers, because they had that ability to support their own things, they were supporting things that were not in the CSS2 specification. The CSS 2.1 took some of those browser supported features and added them to the CSS specification, some of the more popular ones, right? It made a uniform specification for those things, so because we have multiple browsers, so they could all kind of be on the same page as each other. And then immediately starting in 1999, CSS3 began development, but it wasn't officially released until 2011, and it wasn't super popular for a couple more years as well. But what CSS3 did was break apart the CSS specification into modules. So different modules for different features like borders or positioning, they have their own modules now, and they can be updated independently. Which means that officially there is no CSS4, but there are some individual modules which may have been updated to a level 4 module specification as of now, or as of whenever you're watching this. And so some people may consider there to be a CSS4 for those modules, but officially it doesn't exist. There's just CSS3, and there's all the modules. Okay? So that is going to conclude my introductory video to HTML and CSS. We didn't actually learn any HTML and CSS yet. Primarily talked about the fundamentals of how the internet works, and then some history of the languages HTML and CSS. So when we come back next time, we will actually do a little bit of coding, and I'll see you then.